Now we're going to look at the factor theorem. And what the factor theorem says that if we can divide out a number, then that number can be created as one of our factors because it's one of our zeros. And how that's useful is then we can hopefully factor the rest of the polynomial remaining that we have left over after we divide out that zero that we know to find all of the other zeros or all of the other factors. So on this one, it gave us a polynomial and it told us that one of the zeros was x equals -3. So since I know that x equals -3 is a 0, or I'm hoping it is, I'm going to take it out or check on it using synthetic division. And so remember, we want our remainder to be 0 here. That's our goal. That's our key. That's how we know something's a factor or something's a 0. So I went ahead and I set up my synthetic. Now remember, we have x equals -3, and when we have x equals, we actually use the number. We don't change the sign. We only change the sign if it had shown us x plus 3 as a factor. And then I used all of my coefficients, so 1 for x to the 4, -1 for x to the 3, -16 for x squared, 4 for x, and then 48 is my constant. I brought down my first number, or I'm going to bring down my first number, so that 1 comes down. Then I multiply -3 and 1 to get -3. I add -1 and -3 to get -4. I multiply -3 and -4 to get 12. I add -16 and 12 to get -4. I multiply -3 and -4 to get 12. I add 4 and 12 to get 16. And then I multiply -3 and 16 to get -48, which gives me my desired remainder of 0 there. And now remember, the stuff that's left over, that's what creates the rest of our polynomial for us here. So we have our remainder was the 0, our constant is 16, our x was -4, x squared is also -4, then we have a 1x cubed there. And this is going to be our polynomial that's left over after we've taken out the -3 from it. Think of that factor tree. So I'm going to set up my new polynomial, x to the third minus 4x squared minus 4 plus 16. Minus 4x plus 16. And now I need to factor that to find my remaining factors because I want to find the group, all of my groups here. So to do that, since there's 4 terms, I'm going to group the first 2 and I'm going to group the second 2. Remember to follow the factoring chart, the yellow big factoring chart on the wall. And I'm going to take out from an x cubed and a -4x squared, x squared. Since I had x cubed, if I take 2 of them out, I still have an x left. And then I took all the x's out of the second term, so I just have the -4. Now notice how in our 2 groups here, one of them's a negative and one of them's a positive. When that happens, I need to take a negative out of the second group. That will ensure that my signs change here on the second group. So if I take out the -4, I have a positive x, and then 16 divided by -4 is -4. And now see how our 2 groups there are the same, so we can utilize those 2 to regroup and become one group. And then we also have the x squared and the -4 that come from the GCFs on the outside right there. And then don't forget, we have that x minus 3 or x equals -3. So we can't really use it that way as factors. So if x equals -3, if I add the 3 over to the other side, I would have a factor of x plus 3. But take a look over there. I don't see this exact answer. I see ones with 4 groups more than ones with 3 groups. So take a look at that middle group there. There's still a squared on that x. What that means is that that group needs to break up a little more. And that group is actually one of our differences of perfect squares that we've talked about. So remember, when that happens, a difference of perfect squares always breaks up into 2 groups right away. The x is an x squared, so I'm going to split that off into an x and an x for each group. And then remember, our difference of perfect squares always comes with 1 positive and 1 minus. And then the 4, I take the square root of that, which is 2. So I'm going to have a 2 and a 2. And then I can bring down my other groups that I had before, which was the x minus 4 group and the x plus 3 group. And now I have 4 groups there. And so I just need to find the order. And oh, look, I actually put them in order. Didn't even need to do that. But remember, the order of the groups doesn't matter. So even though D matches up perfectly with our groups down here that we have. Remember that they can be in any order. So on these types of problems, they're giving you one of the answers right off the bat. You're dividing it out, you're factoring it out just like a factor tree. Just like if we had a 24 and we factored it into a 2 and a 12, that -3, that's our x here, that's kind of like the 2, it's already prime. But this 12, we have some stuff we have to break up into it. And that's what we did right here when we did our factoring, okay, breaking it down into all of our linear factors.